Hello, everyone, and welcome to a new and special episode of the Tech Cafe podcast, streaming live on LinkedIn and YouTube. My name is Ahmed Misbah, and I'll be your host for today. Please allow me to welcome today's renowned guest, Jeff Langr, who I'll be interviewing today on collaborative development with humans and artificial humans. Thank you very much for being with us today, Jeff.
Yeah, thanks for letting me be here. Good to see you again, Ahmed.
Thank you. The pleasure is all mine. Jeff has been delivering software systems since 1982. He currently works for his own company, Langr Software Solutions, to help companies learn how to build higher quality software with a higher amount of enjoyment. He's the author of 5 books on software development, including the 3rd edition of Pragmatic Unit Testing in Java with JUnit, part of the Pragmatic bookshelf. Jeff also wrote a couple of chapters for the best-selling book, Clean Code by Robert C. Martin. You can also find pointers to over 120 articles and hundreds of blog posts on his site, www. Oh, there's no www, it's just langersoft.com. To our viewers attending the live stream, feel free to send us your questions over the chat, and we'll be happy to answer them at the end of our interview with Jeff. And now, without further ado, let's dive into our discussion with the first question. So, Jeff, the first 2 terms in this episode's title are collaborative development. What do you mean by collaborative development?
Yeah, so I used to basically use this term to kind of talk about pair programming, mob programming, and actually had somebody challenge me and say, look, well, we don't do those things, but we believe we're doing collaborative development. So what I'll typically do is say, maybe active collaborative development is what I might be calling this, where you are working face-to-face with virtually or live with other members of your team, bouncing ideas off of them for most of the development efforts that you're involved with. We're not splitting off into solo development work off in our cubes. We're basically finding a way to get together each and every day to build software as a whole team.
Okay, so funny enough, today there was a post on collaborative programming, and a lot of people were questioning that and saying that costs of having everyone working on the same thing at one time is a little bit questionable. Wouldn't it be more effective to have everyone work on different things?
I've done both. I'm absolutely convinced there's a lot of overhead involved with what Tim Ottinger calls scatter gather, where we basically split up the work into small sub teams, which might be individuals, and then come back together, try to coordinate everything to make for a singular whole. A lot of this goes to working on one thing at a time, which is what mob programming basically says we're doing. By doing that, we start to get rid of a lot of the ceremonies that you'll see on a typical team. So let's just talk about things like daily stand-ups and whatnot. If we're all working on the same thing, we're not coming together every day to figure out who's doing what, who needs to coordinate with whom, and so on. That kind of ceremony disappears. The planning ceremonies start to get simpler for, let's say, if we're doing iterative development in sprints or iterations. We don't have as much of that. Let's get together once every 2 weeks and try to coordinate things. We avoid things like merge hell, where you've got multiple pairs working on in the same code base, and now they've got to integrate the software and find out that somebody stepped on somebody else's toes. So that sort of thing goes away and just gets streamlined. We just come in the morning, we decide what were we working on today, or do we need to finish up some stuff from yesterday? And that's about all the talk we need to do for about 30 seconds to get started. We don't do pull requests. So if the code's getting developed by the whole team looking at everything, then we're all in agreement that it has the quality we need. We're in agreement that it follows the standards we need. And we don't do these post facto reviews in the form of pull requests, which nobody likes to do. They take time, and they don't do a very good job in the first place of making sure the software has high quality. If you want high quality software, you work as one team, you get it right the first time, and you avoid the rework that these post facto reviews necessarily entail.
So thank you so much for that insight. Now, I'm a big fan of lean software development, and I'm guessing you are as well. And what I like about the answer to my question was that what you're saying here is, with collaborative development, we are actually reducing a lot of waste and making the team focus on delivering value and creating that flow, which we all talk about in lean software development, in order to deliver software sooner. Would you agree with me on that?
Oh, absolutely. I mean, you're basically talking a whip of one, or work in process or progress of one thing. Yeah, you absolutely get into that flow, and everybody's focused on the same thing. Yes, absolutely agree.
That's great. Thanks a lot, Jeff. So let's move to my next question. So collaborative development first started with XP's pair programming practice. Some people today prefer mob programming over pair programming. Do you prefer mob programming over pair programming? And if yes, what are the main reasons for that?
Yeah, so from a sensible standpoint, it really is involving the whole team. So we get rid of a lot of these challenges of having this split up work or the scatter gather pattern again. To me, I absolutely personally prefer mob programming more. One of the things I found about pair programming is most of the time with most pairs, things go great, but there's always that one person that, gee, I'm not having fun at all. I had to, about 12 years ago, I worked with a pair. We called him the Mad Russian because he was a little challenging to work with and very dominating. I kind of wanted his way the whole time, and it just was extremely frustrating, not something I was terribly enjoying. I think the problem I have with pair programming is not just all the overhead. You still have to coordinate things, and you still have the notion that maybe two people as a pair can produce some work that's less than stellar quality. You have to review it. So not just the active pair reviewing things is great if you can trust that everybody on the team really understands everything well and so on. Typical teams not usually set up for that. So I always push for the notion of, if you're pairing, you probably need a third party come in. So you split the pair, maybe they pair for the morning, add a third party to come in, and they're going to have to essentially take a quick look and say, well, are you on the right track, or are there problems here? So you still have that whole need to do some little bits of post facto review here. But yeah, I think ultimately I absolutely prefer the mob programming because of the group dynamic. The challenge with, let's say, the Mad Russian or other pairs is going to be the notion that you have to learn how to get along on an individual level, a very intimate level, with pretty much everybody else on your team. That's hard to do. Also, sticking with one person for hours at a time, I think it's just tiring. By the end of the day, you're always on point with that other person. So at least with mob programming, the group dynamic of the whole team being in the room means you can maybe step back mentally from time to time when you need to do so.
Yeah, I'm grateful for your explanation. And this takes me to my next question. What kind of differences do you see between pair programming and mob or ensemble programming?
Yeah, I think I touched on some of those, but I think ultimately the intimacy thing I'm going to go back to. One thing I learned a long time ago, I was interested in being a writer for situation comedies, let's say Seinfeld or something like that. I found that they actually employ, I thought, well, okay, I can do this remote. I can just write up to a script and send it in and see how that goes. And they can let me know where it needs work and so on. But what the reality is for most of those troops, if you will, is they get together as a whole team. They bounce ideas off of each other the whole time throughout the development process. And you can certainly do this with a pair, but having the whole team there to get all the different perspectives in the team, to understand what everybody's where everybody's coming from and what everybody thinks the best possible thing could be. I think getting that total view out of everybody on your team is so more valuable than a pair maybe doing that for a little bit and then having to realize that somebody else comes in and says, well, wasn't such a great idea after all. So yeah, going back to the notion of not having that post facto stuff going on. Higher quality.
So what does mob programming look like in practice?
The name of it, by the way, some people call this ensemble programming because the term mobbing, particularly as a gerund in Europe, has some offensive notions. I view it as always positive. It does imply chaos, right? A mob rule is not a cool thing. Now, a mob needs to be a pretty structured thing. If you let it devolve into chaos, it's not going to go well. So the first notion is, well, we're just going to throw everybody in a room and let them figure out how they're going to work and what's going to come out of it. If you did that, it would typically devolve into one person, probably the team lead, the person with the most know-how in the room, grabbing the keyboard and then dominating the session for, whatever it takes, 2-3 hours to get some piece of a solution out there. Everybody else would be maybe tossing some ideas once in a while and would kind of devolve to that. After a while, most people would be kind of sitting back and, falling asleep, which I tend to do in that sort of environment, not finding a lot of value in it. And if you're going to do that, it's really not worth the effort. The structure mob means that typically you've got a driver person playing a role as a driver for a short period of time where they're at the keyboard. Then the rest of the people in the team, the mob, are the navigators. So the person at the keyboard is not making decisions about direction. Instead, they're listening to the rest of the mob who's navigating, telling them where to go next. We need you to write a test that does X. Oh, okay, I understand that as a driver. I can listen and translate that direction from the navigators into actual code in the system. The rest of the navigators can take a look at the code coming out and say, yeah, that's right. Well, you need to tweak this and so on. So it's a conversation, certainly, but it is with a single driver in place in front of the room. So that's generally what it looks like. It can certainly work live, which is where this obviously all comes from. 𝗚𝗲𝘁 started this stuff about 2010 at Hunter Industries in the US. And so, this is not just a new thing. It's been around for full generation, if you will. So yeah, that's what it looks like live. You would do this with one computer and a large monitor in front of a bunch of folks. A lot of us are virtual and want to stay that way. So we found a lot of effective ways to do this in a remote fashion.
I appreciate your detailed response. Thank you very much for that, Jeff. So we've got a question from John Kern, which is very similar to a question that I had prepared for you, and that was actually my coming question. So he's saying, can you contrast mobbing remote versus in person? And my question was, what about remote work? Do you still use mob programming for that or ensemble programming? And what does it look like remotely?
Sure. So I was at Ford for a few years helping various teams there, and we were doing live mob programming. And the best circumstance was we were able to commandeer, let's say, a conference room and put a giant monitor in there and share a single machine in that room. And I think that's probably the most notable difference here. So we all would get up when it was our turn. We did short rotations, 5 or so minutes, for one person to be driver, and then get up, relinquish the seat physically, let another person sit down and start driving at the keyboard. So that's what it looks like live. COVID hit, and I had actually just established one team where we were doing mob programming starting in January that year, and COVID hit around March 17th or so in the US, and we were very quickly automatically shifted to doing work from home. We started using some tooling a little later, but initially we basically started doing screen sharing things. What was fascinating about it is at the end of the day, first off, when we were doing it live, people would tell me, oh, this is a lot of fun and we're getting a lot out of this. And I think we're going faster. And I had heard that enough times with enough prior teams. The end of the first day of the COVID, pretty much everybody said, we're still having a lot of fun. And even with the world falling down all around us with COVID, we're getting things done, we're able to focus, and at the end of the day, we feel pretty good about what we're able to do. I mean, that was the first day. Everybody's like, okay, this isn't going to be as drastically bad as I thought it was, working from home, being isolated all day. Now, we're interacting all day long. It's a very social thing. Later on, there's a guy named Simon Hare in England who developed a tool called mob.sh. So if you're going to be remote, highly recommend it. Even if you're going to be pair programming and not mob programming, it's a wonderful tool. We call it a Git handover tool, or they call it Git handover tool, where the idea is you're sharing everything through Git pushes, and the tool streamlines it for you. So you create a temporary branch. The tool creates a temporary branch for you. You take the driver's, let's say 5 minutes worth of work, and then the tool pushes it up very quickly, bypassing any kind of constraints like push hooks or whatever. And then the next person in line just uses the tool and says, okay, start the mob session, and then it pulls all that code down to them. So we get handover times of about 10 seconds on average, which is really cool. If you're trying to do 5-minute rotations where someone's driving for about 5 minutes, that's a small fraction of that time. If you did this by hand, you could certainly do that. And I've seen some teams who decided that's the way they wanted to go. It's probably going to take you 30 seconds, 45 seconds, or even a minute or two as you realize, oh, shoot, there is a Git hook here, and I've got to get this stuff cleaned up before I push it over. With mobbing, the intent is it doesn't have to be perfect. The idea is to shuttle it from me to you to the next developer quickly. So bypassing all that and using a tool is a really effective thing to do this. So the big distinction between the live mob programming then is you get to use your own machine. If you like your machine, you get to keep it. If you like your IDE, you get to keep it and all its shortcuts and so on. You're driving, you're choosing to work in your own personal, comfortable environment. Everybody else is still able to contribute and tell you what you want to do next.
So I realized in your answer that there are a lot of benefits from doing mob programming. So can you talk to us a little about that? What are some of the benefits folks can expect to see from doing mob programming?
All right, so everybody's there, so you all have to agree on what quality code is, and it takes a little while to get used to this. So the first few days that you do mob programming, it might be a little rough, but it's far better than having a bunch of individual pairs or individuals go off and produce code that maybe a lot of us don't agree with on the rest of the team. So you're resolving all these problems up front. If there's an issue that arises amongst the team, we can address it right then and there. And in fact, a lot of teams do retrospectives where they come back and look at how did things go the past 2 weeks? What do we need to improve on? With mob programming, you have the opportunity to do that as you're developing throughout the day and as the problems are arising. So you don't have this hour-long meeting where you're trying to remember, what wasn't I so happy about when I was in the depths of working at the code every few minutes. So it immediately, by putting everybody working on this one thing at one time, we get rid of, again, another piece of ceremony. But we all find our way to this same page very quickly early on. And as such, we end up producing a lot higher quality code, code that adheres to whatever standards we put up across the team. We don't have all these ceremony meetings, which I love. I'm not a big fan of going to half a dozen meetings a week to just coordinate things. It just seems a lot of overhead. Ultimately, I think the two things that I remember most, and I learned about mob programming around 2015, 2016, and then started introducing it to teams because what I started hearing is, we're having a lot more fun in working this way, a lot more fun than solo development or pair development. And then I would start hearing teams, not all of them, but a lot of them would come and say, we're going a lot faster. And I'm like, really? And I said, what do you mean? Say, well, if we had, let's say, 5 people on a team, they all went off and did their own things. We're working on one thing at a time as a whole team, and we're still getting more work done in a given 2-week period of time or sprint. Whether or not they were doing lean development, they were still finding things were going faster for them. And I started trying to figure out all the reasons. I've touched on a few of them, but certainly the streamlining of ceremonies is one small piece of it. But ultimately, I think it does have a lot to do with the fact that we've got all the brilliant minds, as 𝗚𝗲𝘁 likes to say, in the one room working on one thing at a time.
Yeah, that's great. So we have a question from the audience. What was the tool to facilitate ensemble programming. So let me just put the link.
John did get it right, but yeah, 𝗲𝗁 is correct in the chat. And then if you want to maybe do the whole link with the HTTPS, that might help. Yeah, and greetings to everybody on the phone, and thanks for joining in. Phone is an old term.
Okay, so we were talking right now about the benefits of mob programming. Now, it's not all sunshine and roses. So what are some of the challenges that can occur in a mob?
So, most people's perception is going to be the mob rule, right? Since it's called mob in the first place. And you can certainly allow a mob where that can happen, where the quorum of the mob kind of decides things, and maybe a couple people in the minority don't necessarily agree with things. And that, I think, is probably the biggest thing that can be a problem in teams. There's ways around it. Certainly having the drivers rotate is important. So there's one key rule about this, which is, as the driver, you don't get to decide on direction, which helps a lot with things like dominance. And you can get, if you don't have the rules in place, you can have dominance where, again, maybe the team lead is driving a lot of the time and making decisions as they drive. So the rule is, again, the driver can't do that. And maybe they come up with good ideas. The rule is they have to get up and explain it to a new driver that takes their place. So at least we're circulating this. It does have the advantage also of getting everybody's skills increased in the area of listening and talking about code, socializing code, if you will, something that I firmly believe is very valuable to be able to solve problems as a team and communicate challenges and how to build proper code. So that's one of them. You just have to keep on top of it to make sure that all voices are getting heard. And certainly I've seen teams where there's a person who sits in the corner and doesn't speak up much. Some of this does require coaching, certainly. I've seen people initially fear it. We had one woman, I was at Northwestern Mutual. She thought it was a horrible idea. So we just talk to her every day at the end of the day and say, well, how did it go today? Is there anything we can do to improve it, and so on? What was fascinating is at the end of 2 weeks of doing this, she came back. She's like, I'm really loving this. And she became kind of a big champion of it at Northwestern, where they were trying it out. So that's great. The one thing I'll say that remains is it's not for everybody. And I will say it's probably most people will enjoy it very quickly. I've introduced it to many, many dozens of teams as I do training at companies and so on, many teams that I've worked in myself as a developer. And there's not a lot of people who dislike it. There are certain personalities, individuals who have a hard time with that kind of group socialization. And so you do have to also watch out and be sensitive of those sorts of things. But I'm going to say that you're talking probably fewer than 1 or 2 in 100 folks that really can't work this way. And we can find other ways for them to work. And I'm a firm believer that each team needs to decide for themselves how they're going to work. So I would never be in favor of every team has to pair mandate or mob mandate, that kind of a thing.
The funny thing about ensemble programming is that if you read about it, sometimes you think it doesn't make a lot of sense, but then when you try it, you completely change your mind. I mean, I was one of these people who practiced it without even knowing it was called mob programming or ensemble programming. But every time we practiced it and got out with a lot of value from it, we always thought, hey, this could work if we can do it all the time. So yeah, it's one of these things that you want to try it out, okay, before judging it, just by reading an article or whatever. So yeah, I like the part where you said that most people would prefer it, but if they decide to try it.
It's just like anything. There's not a lot of rules that I put in place for it. We figure them out. Most of this is team group meeting rule kind of thing. So most companies have rules about how to treat each other nice during meetings and so on. Yeah, they certainly all apply. And then absolutely, you do have to have the sensitivity that everybody's an individual. So if you're in charge of a team or just in the team, it behooves you to go through and sit with everyone as an individual and figure out what motivates them, what gets them frustrated, and so on, and find out what they're truly thinking. And on top of that, find ways for anonymous feedback from time to time. I'm a firm believer that, even if you think you've got a healthy team, you'll find usually it manifests itself in ways that are pretty obvious. But sometimes you have people who will do a good job of acting that they're having a fine time of it, but reality says maybe they're hating every minute of it. And I've seen a couple individuals like that to know that that absolutely can happen. So you do need anonymous feedback gathering mechanisms at times.
Yeah, makes a lot of sense. John Kern has a very interesting comment, which I want to put up on the screen. He's saying, I would imagine that success may depend a lot on the mindset that people have and the degree of safety. That's a very, very important point. The group has amongst themselves. You are very exposed in a mob session versus solo coding. So I'm guessing that safety or psychological safety is a big challenge in ensemble programming. Now, if that doesn't exist, I think it can, turn out to be a very bad experience. Don't you think so?
Yeah, absolutely agreed. I imagine there's teams. I haven't been in one in a while. I actually worked at a company previously. I do have a new job, by the way. I'm at Jack in the Box full time, and so far enjoying it. And we're they're doing pair programming, and I already did a little bit of mobbing, introduced 𝗷𝗊𝘁 to them. They loved it. So irrespective of you doing mob programming or pair programming, you can use the 𝗷𝗊𝘁 tool to at least, when you've got a few parties on a call, let's say you get together to solve some problem ad hoc, just a very wonderful, quick way to share the code elsewhere. But yeah, I was at a job previously, let's see, ended in 2023. And they talked a lot about safety, but when it came down to it, they did some things that were extremely unsafe. So I think it's highly important that you feel safe. It's going to manifest itself very quickly, though. In other words, yeah, I think my problem with not doing this whole team collaborative development is problems tend to fester in the cubes. Once we start getting together as pairs, we start realizing, there's interaction issues that might help rise to the surface. And I saw that for the prior couple of decades that I'd done a lot of pair programming. With a tool like this, and it is a tool, I've been on teams where they kind of employed all three, solo, paired, and mob development. With a tool like this, it's going to come to the surface immediately within the first few days if we have a serious issue that we can't resolve. And I've seen a little bit of that. There's kind of two varieties. One is somebody who wants to dominate and isn't happy with the ability for that to not happen. And two is the person who just, they want to be a wallflower. So neither of those work, and we can certainly start looking at addressing it. Maybe have a sub team, one person works on their own on that team. Problem is it starts to detriment the whole team to have to worry about the other person off there doing their own thing. So I do believe it does need to be a team decision, and there may well be teams where you do have strong personalities or extremely weak personalities who it's just not right for. Most teams are not that bad. Often most people are willing to adapt. But yeah, safety rules have to be established just like they would in non-mob or paired environment.
So I think people who are aware of modern agile values by industrial logic, or perhaps just Joshua 𝗘𝘅𝗃𝗏𝘃, I'm not sure who's the inventor of this, but it's definitely industrial logic. So there's one value which is make safety a prerequisite. So do you think we need to make safety a prerequisite also for mob programming?
Absolutely. Yeah. If I don't feel safe, I start contributing less, and that's a detriment to the company and team. We can't tolerate people stepping on top of other individuals within the team. And again, I contend that it's going to happen far more frequently in a team who's doing solo development and not be noticed and just create new problems that fester for years on a team. I've seen that firsthand. With something like this, you'll at least elevate the problem to the point where hopefully people notice and figure out we have to do something about it.
Yeah. So since we are still talking about the challenges I want to put on the screen Paige Watson's question. So he's saying, we had a team member from a company that I was consulting with who was worried that they weren't receiving credit for their work in the mob. Very interesting. What are some of the ways to handle that at a team member level and at a company level? Now, I know we agreed that we were going to take questions, but this is actually very important, and you know.
Yeah, to me, this one is always interesting to me because I've not really seen this come up. I've heard, you know, a long time ago, we had similar problems. We're working on a team and we were all committing everything as a team. And it's like, oh, well, we're not seeing commits from individuals. And how are we supposed to know all this? I think it's important that does need to go very high in the company level to recognize it's not individual work. It's the team's getting quality software out the door that's earning the company money. We're going to know, first off, as a team, we can do some level of peer review, and I've seen this work in some places. It's got its own problems, but the team, obviously, when you start working together at this intimate level, they're going to know who's really putting up and trying hard, coming up with ideas and whatnot, versus people who are just kind of staying in the shadows, the wallflowers, if you will. So I think you do probably have to change how your review processes work if you're going to employ this for the better, rather than start trying to look at things like individual commits or something. If you're a manager, by the way, we invite everybody to sit in with the mom, not just the developers on the team, not just the analysts, not just the testers and so on. We're all one team working. People can come and go in the mom. We do invite outside parties to sit and pair. We invite the managers to come and sit and develop software from time to time. So a lot of them have this in their background. So they get to get their hands a little dirty, and everyone loves it. They're like, okay, this is cool. I really enjoyed that. All it takes is for a manager to sit with the team from time to time, or talk to people on the team to very quickly figure out who is really the drivers of the team versus who's maybe not putting up as much as they should. But ultimately, you know, my belief is it's really a team effort. And to me, there's no better tool for putting a team together and getting them to cohere to the point where they're delivering the stuff that business needs to succeed. I'm sure there's probably good answers from folks on the line. Thanks for the question, Paige. Anybody else come up with a good answer to this one? I'd be curious. It's not a problem I want to have to worry about solving, and I haven't had to look at it, to be honest. Well, if somebody comes up with another answer, maybe put that one up. But,
for sure. Okay, so we have covered collaborative development with humans in our previous questions. Let's move now to collaborative development with non-humans. So what does that mean?
So I got laid off and I found myself doing a lot of work at home for starting around November. And I started realizing we touched on, I'd used the LLMs, ChatGPT most predominantly, prior year or so. I'd started playing with them and taking a look, and we'd done a little bit with doing some code generation with them on one project. And I thought, okay, this is kind of cool. I was pretty skeptical, like most developers are. But the more I play with it, the more I realize there's a lot of potential here. I think the tooling is better than a lot of people will expect. So around November, I had a lot copious time, and I started playing very in depth with generating code with the AI tools, or LLMs predominantly. So ChatGPT, Claude, Meta.ai, and all these tools that are out there. So that's kind of what I mean by that. Rather than working with a team and a mob, I was off on my own. I'm like, I want to build quality software. What would be a good way to do that in a more rapid fashion?
Oh, that's great. So Gen AI, or generative AI, and LLMs, large language models, are very well integrated today in software development, especially in coding. Tell me more about what you're doing with Gen AI and LLMs to generate code.
Sure. I played a little bit with the things like Copilot and JetBrains AI Assistant and so on, and I've used them here and there. I still use the AI Assistant and JetBrains, and they're kind of nice. They get things wrong enough. They're like, so here's a complete, so I just ignore it and whatnot. But in my head, I thought, well, that's nice, but maybe the thought is I shouldn't be writing as much code in the first place by hand and incrementally. I love coding. So the thought of this was kind of weird to me, to think that I'm going to seek out solutions where I don't have to code as much. And then I thought, well, really, that's what we should always be trying to do. And if I don't have to code something, the best solution is find it. Well, this is the what they call it, low code, where you're pulling stuff off the shelf to integrate. I don't have to code it because it's already been coded and trusted. So my thought was, what if I start looking at this at a larger level, rather than using AI tools to assist with individual statements in code and that sort of thing? What can I get it to do at a larger scope, class level or module level? So I came up with this notion, and I'll tell you what, if you sit down and think about this for about 10 minutes, you come up with pretty much all the insights you're going to need to do this successfully. The first key insight was, well, if I'm going to ask it to generate code, why don't I also ask it to generate the tests as well? So, unit tests typically, but they can be other kinds of tests, integration tests. It does a pretty good, the tools do a good job with those as well. But what if I have it to generate all the tests that I'm putting in play for a given module? And let's say I have a small module, maybe 50 lines worth of code or whatever. So I can sit down and think of, all the requirements to give it. When it generates it, generate the unit test. The second insight, so that means that I've got the code it produced and then the test. Before I get to the second insight, the first rule of doing all this is to remember that it's going to get it wrong from time to time, certainly. And ChatGPT reminds you at the bottom of every page that you trust this, maybe, but verify it. So that's become kind of my prime directive, if you will, this whole trust but verify thing, which comes from the 80s and Glasnost and all that stuff. So I have it generate the test. I run the test and make sure it's correct. If it's not correct, I've got some ways to go about getting it to correct itself. You can certainly start to have a conversation with it. But first and foremost, create the test. Second, vet the test to make sure that the tests are in alignment with what you're asking for. So take a look at each one and say, yes, that is accurately, that's an accurate depiction of how I've described the needs for this class to you, or this module to you. Or no, that's kind of a problem. Let's fix the test first, and then we'll try again to have you generate the code for it. What's fascinating is if you start thinking about that for about 2 minutes, you realize LLMs do pretty well with examples. So rather than describe all this in a very English language format, I describe tests. So given this input, produce this output. Input is ABC, output fat arrow should be capital ABC. And the LLMs are smart enough to understand that's an example. I describe the example. So should capitalize lowercase letters. There's a simple description. The LLMs do a wonderful job at translating those directly into the unit test. I can pull up the unit test, and I'm going to say with very high fidelity, probably 99% of the time, what you describe in the example is going to be exactly how the test is represented. The one-line description you gave of this scenario will be the name of the test, and then the example will be played out exactly like you provided the example in the to the LLM. So that's great, which means you can very quickly scan the test now and see if they have fidelity with what you were originally asking for. So those two insights alone, one is to basically generate the test. Two is to use examples to help in doing so. That improved what I was seeing dramatically very quickly. The third part of things that's involved with this is, once you generate the test and code, vet the code, then you run the test and find out if they pass or not. And I was finding it's like about 80-20 kind of a thing, where 20% of the time, some of the stuff it generated was failing. Adding the examples increased that number. And then the third insight was, give it a style. The code that the LLMs produce is pretty much old school code, very procedural, top to bottom, not very pretty. It puts comments in to try to help things out. And I'm like, this is not the code that I'm not going to be able to extend easily or understand easily if we get into a problem. So I established a handful of style rules. Actually, I started initially with like a dozen. I realized it was way too many. The context window is kind of limited in terms of remembering to apply them all. I'm presuming that's something that's starting to improve. I haven't seen a lot in the past few months, but things are, as we all see, are changing very quickly here. But yeah, I reduced that to about a half a dozen rules, and the core thrust of the rules is have a design code that is very functional in orientation and very cohesive. So small classes, small methods, small functions, small modules that are very focused, that do one thing, and that we ideally can look at as closed when we're done with them. And I found that bumped up my percentage of chance of success even further. So the examples helped a lot, and having it define a style helped a lot. And that immediately brought up the quality of the solution to some extent. The better thing that happened is when it does get things wrong, and it still does. So now I'm thinking it's more like 90-10 rule. Maybe 10% of the time there's a problem here. When it gets things wrong, the conversation I can have with it about the things that went wrong goes much better. I can start having it focus on the individual method that was, we introduced a new requirement. It's a problem. I know where the implementation is. I can very quickly go to it and start saying, well, let's try to have you regenerate that. Let's add some tests around that focus method if that's going to help you do a better job. So having a good design in the first place meant, first off, it produced a better solution. Secondly, I had a much better chance of fixing the problem. And third, as I add new things into the mix, I've got a better design solution, something that's hopefully more pluggable or a plug and play, where I can start dropping things into place. So all the stuff we know about good design, I think, still applies for the time being until it can get everything correct based off of your examples. And I think that's still some years off. Pipeline pattern is a wonderful pattern to say, okay, break this down so that you can just throw new functions at it as you desire. Start looking at command patterns, start looking at strategy pattern as things that isolate and close off the rest of the system, so that if you have new behaviors, you can just drop them in place, vet them fully with tests that you generate for that new code. So that's kind of a long overview, but I think that's the core of this. How I've been approaching it, and it just continues to be valuable. I'm building a plugin that will help streamline all this, because right now, if you interact with a chat engine for the LLM, you have to do a lot of copy, paste, and manual manipulation. So I'm building a plugin that will streamline it, but I'm also dog fooding it, so that I'd say at this point, probably 70% of my effort has been generated, and the other 30% I'm kind of doing some mucking around. A lot of it's with the UI. And that can be a bit of a nuisance to muck with the generated stuff. But yeah, it's being increasingly more valuable to my development. I'd say I thought I went fast before. I think I've almost doubled my speed since starting to do this.
Yeah, thank you very much for this detailed response. And I think you've mentioned so many important points, which I will be asking about in my coming questions. But first, I want to ask you about GitHub Copilot. Where do tools like Copilot fit into all of this?
Yeah, well, I still find myself doing coding. Certainly, I'm very picky about code. Every last little character has to be in the right place and following my preferred style. When I'm coding for myself, when I'm with a team, I follow their style, and I also try to impart a lot of my pickiness on them where it produces the value in doing so. So, we're still going to find ourselves coding things from time to time to fix problems that it's stubborn about. I've had cases where the LLMs will spew out the wrong answer for one of the requirements, and we've had to get in and fix that one thing, because you try a half dozen times and eventually it comes back and keeps giving you the wrong answer. Eventually comes back and says, well, here's an answer. I'm like, well, you already gave me that 5 times ago. So sometimes it kind of gets caught in something that it just can't resolve. So certainly for the time being, being able to get back into my IDE and hand code things is still going to be something that's essential. I also like to do a lot of refactoring on the code. I realize my goal is to get to the point where I can close a class off and never have to look at it again. Having said that, I still have this compulsion to get in and clean some things up that I'm pretty unhappy with, and I'll do a lot of that sort of thing. So I will still use the refactoring tools. Sometimes we've got legacy code too, certainly. So when you're in a legacy code base, one of the best things you can do is start improving the design to give the LLMs a better chance at helping you with new modules that are now, in a new separate class that we can focus on and have it generate code for. But you still have to deal with this legacy code. You still have to factor it to this better design in the first place. So tools like that are still going to remain valuable for some time.
Yeah, makes a lot of sense. So GitHub Copilot is a model specifically trained for programming work. Yet you and many other people, including myself, are working primarily with ChatGPT. Why is that?
It's where I started. It's efficient. I started this experiment, when ChatGPT 3.5 was the predominant LLM out there. And I found it did a pretty good job. With 4, it's done a better job. But what I'm trying to do is, I don't think that the tooling is only going to continue to improve, and very rapidly so. So my thought is, I was more concerned about having a process to make sure that people are building code that they can at least in one way demonstrate whether or not it's correct. Actually, multiple ways, because you can certainly have it generate multiple levels of tests in your testing pyramid for you. So yeah, I wanted to make sure that whatever I came up with would apply to the lowest common denominator tools, which certainly 3.5 was at the time. It's like, okay, there are tools that are better trained toward programming development. They keep coming out. I just saw one like last week announced in all my feeds that there's yet another one of these tools that promises to do programming better because it's been trained more heavily on it. So great. When they come out, I start trying to use them. But you can certainly start with ChatGPT 3.5 and type all the darn stuff into its little chat interface and deal with it. Works fine.
Yeah. So ChatGPT and similar tools or models produce code that isn't so great by default, as you've mentioned in previous answers. Have you found ways to get it to improve things?
Yeah, it's mentioned, the style rules help a lot. Putting in, half a dozen rules geared towards functional, cohesive things. I think that's done a dramatic created a dramatic improvement for the code it's generated for me. My only problem right now is, I guess it's related to the context window. So in, let's say, ChatGPT, you can define your own custom chat agent. So I've created one called MCP, if anybody understands the movie reference there. I created one that embodies the half a dozen or so rules I have, and I find it just forgets from time to time. It remembers that I want JavaScript code most of the time, but last week I caught it giving me Python code out of the gate. And probably a little more frequently, it forgets a lot of the rules about creating functional code with small functions and whatnot. So you have to keep reminding it. So that's, I think, my only complaint. But yeah, give it some style rules. It'll do a pretty good job of producing decent enough code. And I've also learned to distinguish between perfect code that I would code, not perfect, but code that would follow all of my little rules for how code needs to look, versus code that's good enough to go forward. And good enough is, I understand how this class is constructed and how it interacts with other things through its interface points. And I'm not so concerned about the implementation of any one single method. So it might, let's say, use old school loops to do something, whereas I would have coded this with, let's say, a Lambda-based stream solution in Java or whatever. I don't care about that anymore. As long as I know this code works, it's tested, I can manipulate the code in that function as a isolated entity, move it about places easily enough. I don't care how it's implemented. It's not as important. So a lot of my concerns have gone more toward the macro side of the fence. And as such, I think I've sped up a good deal.
So sometimes the solution generated by GenAI LLMs is incorrect. Have you found ways to increase the chance of building a correct solution?
Yeah, I mean, a lot of this does go toward the providing examples in style, but it's going to get things wrong from time to time. And I'll take two algorithms as examples of things I've futzed with a number of times. So one is this thing called name normalizer. If you go to my GitHub, which is at GitHub/JLANGR, you'll find this name normalizer project that you can pull. And it's really designed as a kata. The idea is, given a name, a Western name like Jeff Langr, return it as Langr, 𝗂𝗃, so in last name, comma, first order. And then you can start adding requirements like, what about middle names? What about suffixes? What about Madonna and Plato, and so on? There's a lot of cool little rules you can add to this to make for a nice exercise, usually around test-driven development. I found it does a pretty good job, except when it gets to the one for suffixes. And the idea of suffixes, let's say we have Martin Luther King comma Jr. The rule there is split it on the comma and then reverse the rest of the name. So it's Langr, King, comma, Martin, L. comma, Jr. So it should take the suffix and tack it onto the end. If you give it all the requirements to that point, which, you know, enough to do middle names, multiple middle names, and so on, there's about 8 or so requirements that would come first. It often chokes on that last requirement. And when I say often, it's probably about 80–90% of the time it does not get the code right. And, you know, I've done a few things. I found, first off, that stepping back to a smaller core set of requirements, getting it to build that successfully. So in other words, take the suffix requirement out of the mix, produce a solution with only the first 8 requirements, and then add this 9th one. Can be little advantageous. You then add the 9th one and it seems to work sometimes. By the way, I didn't mention earlier, but I'm a big proponent of test-driven development, written a lot of stuff on that. And there you're producing every test as an incremental step. So step 1, do Plato, because it's a 1-word name. Step 2, do Jeff Langr. Step 3, do multiple middle names, and then do multiple middle names. So each one is an increment that slowly expands the scope of the software that we're building. So I love that. And yet I find that with doing this process, this create, assess, execute process for LLMs, I can give it a half a dozen or even a dozen requirements at a time, and it's usually getting most of them right. It does start to get things wrong when it has to do kind of backwards looking things. It's produced a solution that's not fully functional perhaps, and it's looking at state earlier in the method and so on. So backing up, taking that requirement out, and then asking it to produce a new solution sometimes works, sometimes it doesn't. But again, this is where you have the conversation with it and start to have it do things like, let's put some focus tests around this. Let's do something else, like reconsider the design of this. What if I created a mini pipeline? So this problem with the name is basically normalize a base name and then Jeffrey John Langr to Langr, Jeffrey J. And then just create a pipeline that says, okay, step 1, strip, if it's Jeffrey John Langr Jr., strip the suffix off, step 1. Step 2, normalize the base name. Step 3, append a suffix to a name. So those 3 things, it can absolutely get correct like 99% of the time. So, this is where you start have to think and start to think about, how do I solve this problem in a more functionally oriented way, or way that is more, again, has close pieces of the solution. So that's worked. Another example, and I encourage you to take a look at the name normalizer. There's like examples in every language. The other one I've done a lot with is this SoundX algorithm. And in brief, it's an algorithm that's been around for 100 years to take a human last name and encode it into a 4-character code. And the idea is similar sounding names will encode to the same thing. So we can help people find people by last name, even if they typed it incorrectly. So my name, Langr, is Langr, but you can certainly put an E in there, and you can put extra R's in there, and so on. In any case, if you go look at the SoundX rules, you can find them at Wikipedia. The rules are pretty straightforward. You're just encoding 1 character at a time. And then there's rule number 3, which says, oh, well, if these 2 characters in the original name are adjacent and they're the same encoding, then only keep one of those encodings unless they're separated by an H or WY. But if they're separated by a vowel, do this, and so on. So you have to kind of look at each character and then also compare it to prior characters. And that's the requirement that it chokes on. So I'm getting more and more a sense of what kind of requirements do these LLMs choke on from time to time. And that's certainly anywhere where it's kind of got to do backtracking, looking at previous things and deal with stateful solutions. And it starts, solution likelihood of being correct is much lower.
Yeah, that's great. So I have a question here, and I think some of the viewers have the same question. So if we want to leverage all of your experience and the work you've done with using LLMs, so you've said you've got sample code on your GitHub account. Is that right?
You talking about code that I've produced with using the LLMs to generate the code?
Not just the code, the prompts, the styles, the examples, etc.
You can take a look. It's kind of in a state that could use a bit of work, but you know what? Go ahead and I don't care. There's something called AADV-plugin2 on the GitHub, which is the plugin, and this is the one that's public and demonstrates the most of what I've done things, how I've done things here. One thing you'll find in there that's it's hard coded now. I'm trying to build it so this is all configurable within JetBrains products, but right now it's hard coded. So I hard coded the list of style rules in there, so you can find those as well. And I think it's like I said, it's only like maybe 5 or 6 different rules. You can think about it. There's rules at a programmatic level with a certain language. So my rules for Java are going to be a little different from JavaScript. And that's the kind of thing I'm trying to build into the configurability of the plugin. But there's also just general style rules like, hey, let's go functional with this stuff as much as we can. So yeah, take a look at the plugin. You'll probably note the places where it's just wholesale generated code versus where I've been manually mucking with it. My apologies for the code at this point. Not exactly what I consider pristine code. But yeah, that's your best bet at this point. And I'll try to get more out there in terms of the style rules and stuff. These could be great article ideas.
So I was one of the lucky people who attended your AADV class. And I think you've done this class at least twice after the class I've attended. So I was wondering if you still offer that class, because this is where, you know, people can learn all about using LLMs for generating code and even refactoring code. So do you still offer that class?
Yeah, probably on the weekends. I started a new job, so it's one of these, ooh, I got to be careful about the vacation time I use. There is a constraint on it at this company. So, you know, if you're really interested, honestly, I'm happy to give folks a little bit of one-on-one time and kind of step through things. So half hour here, hour there, evening times and weekends could work. I'll be happy to do that. Meanwhile, I'm working with somebody else to see if we can get this going within a company to promote building software in this way. My thought is, you know, we've got teams of 4 typically, or 4 to 6 folks in a lot of companies. And I think we can start, there's no notion I have of getting rid of developers, but I think we can make our team smaller. So maybe a pair coupled with an LLM is sufficient for most of our needs. LLM acting as a third party to that. I think we'll produce code faster than, let's say, a 4 or 5 person team in that way, whether or not the team's using mob programming or whatnot. But yeah, right now I don't have the bandwidth to offer the class, unfortunately. But if you are interested, just send me an email. I'll be happy to find some time for you.
Yeah, because I see there's a lot of discussion on LinkedIn regarding, you know, where can we find examples, where can we find the styles, etc. So I remember, of course, we've learned all of that during the class. So that's why I brought it up, you know.
Fair. Okay. Yeah. Like I said, look at my LinkedIn feed. Also, I'll start posting more on there as I find time. First 2 weeks of the job are almost up, and now I can start breathing a little.
Yeah, perfectly understood. Okay, so what do you do when the code still doesn't work? I mean, the code that is generated by a GenAI LLM.
I think that's kind of what we were just getting into. Step back for one, have the conversation with it, you know, add tests and so on. You know, I think there's one big thing here about responsibility, by the way, and we got a couple minutes left, and I think we're going to extend this a little. Also for people who wish to stay. But I think we have a responsibility. And one thing to recognize, first off, is all the crummy code that the LLMs are producing is because we produce all that crummy code in the first place. They're trained on your GitHub repositories, my books, your articles, and so on. So for one, I would love to see the quality of the code that goes back into what it gets trained on in the future be improved a bit, but that's going to be kind of hard to do. But I think the bigger thing to remember is we're going to very quickly produce probably more code than has been produced in human history to this point in time over the next few years, just because we can using the AI tooling. So I think it behooves us to remember always that it does need to be not just garbage code. It needs to have tests to demonstrate that it's actually doing what we expect it to do. So that means upskilling around how do we write the proper test or examples to generate the test in the first place. So we do have a responsibility here. Otherwise, this is just going to get out of hand. There's an amazing amount of bad code now. It's going to get worse until it gets better.
Yeah, makes a lot of sense. So don't you feel a little conflicted focusing on both collaborative development with humans and collaborative development with AI? And perhaps I want to also ask another question, just rephrasing this one. Do you feel a little conflicted focusing on development, normal software development, and development with AI in general?
Yeah, I mean, I feel a little split personality here. I mean, it's a tool for one. Mob programming is a wonderful tool. So is working with an AI agent, and you want to use the one with the right context. A lot of companies aren't touching these yet. They've got a lot of concerns about their information getting out there, helping train stuff or whatever. So there are concerns still, which means I'm still developing by hand in teams, and I love it. I mean, again, I absolutely enjoy both aspects. I don't feel like this will do away with jobs. It will transition jobs. So if you're doing something very simple from a programming sense, let's say just generating a simple web front end. If that's all you do for a living, I would probably find a way to learn some more things, because ultimately the bulk of that will be far more rapidly produced with an AI agent and maybe a person spending a lot less time building it in the first place. So as with everything in human history, something new comes along, and if you don't figure out how to move to the next level, you're going to get left behind. So there was a quote that I showed in the class, something from last year, and it's AI is not going to take your job. Someone else using AI will, I think, is right now the reality here. So learn it as a tool. I wouldn't say you have to embrace it and use it wholesale like I have, but at least understand what you can get out of it, where it can speed you up and so on. I'd say, as mentioned, I'm probably close to double the speed I was before I started employing the tooling for my work.
Yeah, that's great. Okay, so moving to my last question. Now, all of these Gen AI LLMs out there and the tools, the AI coding assistant tools, they're all backed up by big companies, okay, that offer these tools obviously for fee and to make profit. And not all of these LLMs and tools are open source or for free. Now, what if the profit wasn't there tomorrow for these tools or these LLMs and all the major players went bankrupt? What will come of all of this era of AI assisted development we're living in today?
Right. I mean, first off, I think the profit's not even there today for most of them. I'm wondering who is making profit. I wish, I haven't read enough to figure that out. Thankfully, I'll be retired when that happens. I'm 60. I got maybe 5 to 10 years worth of doing this, and then we'll see what happens. It's like the rest of the market economy, which is there's a lot of players in it right now. And I think you're going to see some of them disappear because they can't cut it. The profits are, negative profits is not good for anybody. So a lot of them are going to disappear. Some of them will get bought out, picked up by people with deeper pockets. In other words, some people are going to advance from the minor leagues to the major leagues. So you might see some of the big names disappear, but some of the better tooling elevate and become the leaders here. The reality, though, is there is far, far too much benefit to, I think, humankind than there is cost. I mean, right now you've got huge energy costs, but we're already seeing where people are by not just one, but multiple orders of magnitude reducing the energy cost to do a lot of this stuff. So you're going to see all this very dramatically and very fastly improve over the next few years. The coding abilities are going to improve and so on. It's just, there's far too much. I mean, even with just energy costs, I kind of play that against what is the value to humankind and the energy or lives that were saved because of it. So if you look at the past few months, there have been a lot of big advancements in just looking at antibiotics and coming up with combinations of chemicals and drugs and whatnot to produce antibiotics and new drugs that will actually work better for humans. There's been at least 2 or 3 major announcements on that score. So I imagine you think of all the years otherwise it would take to come up with these developments and count the energy saved in human capital saved in having to spend those many years to come to a solution that better serves us all. So this stuff is inevitable. I mean, I think it's going to be, we're going to get to a point where it can produce most of the code we have to write, maybe 5, 10, 15 years out, who knows. We'll still need humans in the mix because there are always going to be cases where human ambiguity demands that we tell it, in a better way what to do correctly. So the examples are one area where there's a skill that you want to come up on is, am I writing enough tests? Am I describing what I need accurately enough for you to, as an LLM, build it without the ambiguity and defects that would otherwise go out in production? So, this is inevitable. It's not going away. I view myself as being mostly not necessary in about 15 years, maybe sooner. But meanwhile, I'm loving it. I'm still able to capitalize on all my skills as a developer. I'm able to start looking at more macro interest in terms of producing a solution that's better extensible than what we have today. Still able to get my hands on the code from time to time. So I think there's still a lot for people to enjoy about introducing AI more into their workload. But yeah, thanks for having me to chat through all this.
Thank you so much for your insights, Jeff. Now, I want to take the last few minutes of this exciting episode to talk a little about your recent book, the 3rd edition of Pragmatic Unit Testing in Java with JUnit. Just tell our viewers a little bit about this really great book, the 3rd edition. I think it's in beta edition now.
Yeah, so it's first thing, talk about conflicted. I just published a book on unit testing, and it includes things like refactoring and whatnot, getting your hands dirty in the code, right? I mean, it's all hand-coded. I felt like, in 2024, I better talk about where AI fits and where does unit testing fit. I mean, are they completely like... So there is an example. I did it in January of using ChatGPT LLM to do all this. And I think it's the kind of thing that should play out. So this whole process of just create the test, add a style to the mix and so on, that's kind of echoed in a lot of bits of the example. And I think those things will still be valuable 5, 10 years from now, even when it can do a 90% solution or 99.9% solution. So that's valuable. The rest of the book, as mentioned, it's the 3rd edition. The original book was published by Dave Thomas and Andy Hunt way back in 2003. I did a 2nd edition about 9 years ago. And so this is up-to-date Java. I was kind of forced into the issue because they were marketing the 2nd edition, which has Java 8 on the cover, which doesn't play too well. So this is all up-to-date stuff. And I kind of overhauled the whole thing, all rewritten, streamlined, and I think try to put more humor into it this time as well. So there it is. It's out in beta now, so if you want to grab it, go for it, even if it's just for the 1 chapter on AI. So there's another place where you can get an idea of how I'm approaching this. But it's already out of date. It's 5 months out of date, that one article. Things change fast.
Yeah, things are changing fast indeed. So I'm doing a little bit of marketing for the book because I've already read it, and I think it's a great book, and I want to advise everyone to buy a copy of the book because it's a really great book.
Yeah, thank you.
Okay, so that brings us to the end of today's insightful discussion with Jeff Langr. Jeff, thank you so much for sharing your expertise and valuable perspectives on collaborative development with both humans and AI. It's an absolute pleasure having you with us today.
You're welcome. Thank you for having me again. Really enjoyed the chat.
To our viewers, thank you for tuning in and participating. We hope you found this session as enlightening as we did. Don't forget to check out Jeff's work, including his upcoming book, and stay connected with Tech Cafe for more engaging episodes. Until next time, take care and keep innovating. Thank you.